Hello, everybody. My name is Roman Giel from the Jinko Solar Company. We are just in a small, we have honor to present you a small presentation about our innovations in bifacial technology for P and N-type modules, how it is possible to boost efficiency and power density, and our newest developments. I'm in the industry now for nearly 18 years, and yeah, working for the Jinko as a business development manager for now around about 5 years. Let's jump into the presentation, I think. First of all, just one slide about the industry trends. The main shift in the past has been done, shift from the poly to the mono. And, the mono are more or less based on the mono PERC technology. And you have even partially passivated contacts. And you have even the same N-type and P-type. This is the main trend from the P-type mono PERC to the N-type mono PERC. And the next trend is in the market now coming up more and more with percentage in the market for bifacial. Bifacial technology is very well known for many years, but right now it's becoming more and more important. And you can see here the increase in the orange column. This is a forecast up to 2029. It's a little bit much, but take a look here at 23. This is in the near future. You have really around about 40% of the bifacial that is to be expected. Here you can see our latest developments starting from 2012 with a standard poly with 3 bus bars. And you see here an increase of efficiency in mass product of year for year around about 0.5% annual growth of efficiency of the cells. You can see here one of the milestones with 21.9% in 2018. And right now, 2019-2020, we have a P-type with 22.9% to the N-type in 2020, more or less to 23.8%. And this is again thanks to, first of all, the shift from poly to mono, thanks of all to the shift of increasing of the bigger cells, 156.75 millimeters, 158.75 millimeters, and right now to the bigger cell size. And you can see here even the different module types that are coming out of this. In general, it was first of all a full cell, and then we cutting the half cell with multi-boost bar, half cell with a tiling ribbon technology, and I want to show you how it works. Yeah, this is our standard product portfolio in 2020. We talk about the Tiger monofacial. This is the so-called TR with 60 pieces, with 72, 78 pieces, and even the Tiger Pro. This is the highest development, 72 pieces. And you can see here even the bus bar technology. Right now with the TR we have 9 bus bar. With the Tiger Pro we have a multi-bus bar. That means up to now around about 10 bus bar. The cell size is for the TR 163.75 millimeters. Tiger Pro has 182 millimeters, and all in all they are using the tiling ribbon technology, and they are based on the half cut technology. So tiling ribbon technology, as mentioned before, this is a very interesting type of technology, for we are avoiding every cell gap between the cells in the laminate of the modules or of the modules. First of all, again, I mentioned it again, it's a half cut technology. You can see here, this module is divided in 2 pieces, in 2 halves. And we are just talking about multi-bus bar. That means 9 or 10 bus bar, whatever type of module you have. The TR has the 9 bus bar, the Pro has the 10 bus bar right now. And tiling ribbon means, first of all, we are using cell connectors. The cell connectors are round, you can see it here, and after pressing process, they have a flat area for the better contact. This is here in between the cells. They are overlapping. In these overlapping zones are lying with round ribbons, tiling ribbon, and the lamination is done with a high viscosity EVA that is filling the gap between. So at the end, this EVA is, as mentioned, like a buffer, like a high viscosity buffer. That means we avoid the risk of damaging the cells or breaking the cells, and the contacts are made only by these tiling ribbons. So at the end, we improve, thanks to the half cut technology, the shading tolerance for the splitting of a full and a half cell. And we have reduced the current in both halves to 50% of current. So the losses are lower, so the resistance is lower. And the tiling ribbon technology eliminates the cell gap, is a little bit improving the absorbance of the light for internal reflections, is improving the internal resistance that is lower. And again, the transmission of the current is improved. Yeah, at the end, compared to the 5 busbar, you can see here the Tiger modules have a better performance at low irradiates. That is thanks to the better absorption. That is thanks to the light, thanks to the lower resistance. And at the end, you can compare here the 5 busbar with the 9 busbar or 10 busbar technology. The power gain is again round about 0.5 to 1% better in the lower irradiation environment. And this is really an advantage if you take a look at all the fields, the sites that have installed megawatts of panels. So even with 0.5%, 1% makes at the end of the lifetime the difference of the ERR and the LCOE costs. Next point in this very important is the IEC 61215. Very important, the reliability. The borderline is 5% of failure rate. Up to now, conventional have not been bad, quite good and very reliable. But now we are proud to say that the TR technology, thanks to this tiling ribbon technology, has improved even this 2.8% failure rate conventional. For the PID, for example, it's falling down to the 2.73%. And it's again with the TC thermal cycle test 200, it's nearly 0.5% better for the TR. And damp heat test and combination tests really 0.1. In combination test, it's much better. So the reliability is higher. So this all ends up in an advanced warranty for the Tiger Pro series. Monofacial, bifacial. Bifacial has 30 years of warranty, monofacial 84.8%. At the end of 25 years and 84.95 at the end of 30 years for bifacial. The degradation first year is 2%, annual degradation is maximum 0.55% for the monofacial and 0.45% maximum for the bifacial. So at the end, again, you have starting with 98%, you end up for the bifacial with 84.95%. Again, this improves the LCOE costs and the ERR in big sites and makes the difference between the panels that you are choosing. Here, bifacial solution, we offer both. We have a transparent backsheet that's made by DuPont or a dual glass. The main difference, if you ask me where to install what, is bifacial with dual glass. I would use the dual glass version only in water regions, that means floating projects, or in regions with high aggressive surroundings like desert storm, something like this. And I think this is the best choice. In all other conditions, I would always use the transparent backsheet, for it has a better performance for the heat dissipation. It has a lower weight, around about 8 kilos less. So costs for BOS installation, transport, and so on are lower. And again, this is better for the ERR and the LCOE cost. So one point, as mentioned before, dissipation of the heat is much better for everything what is in the glass. The dual glass stays in the glass. This is a good sentence. But this is true. And even the insulation effect of a second layer of glass is higher. And one point not to forget, the infrared transpiration. That means the absorption for the cells from the rear side for infrared light is through a transparent backsheet a bit better than for dual glass. All in all, you have lower operation temperature and even a little bit better absorbance of infrared. That means the performance of transparent backsheet dual glass is better than the same as, transparent backsheet as for dual glass. So at the end, the decision for your choice is made about where you want to install them. Yeah, next point is take a look at fixed tilt or tracking. We have now the benchmark and take a look at the monofacial with fixed tilt. And with tracker monofacial again, you have an advantage. You have a more power gain with 9.6%. The bifacial fix compared to this benchmark, bifacial standard 10.4%, and the tracker has 22.6%. So this is really worth the installation and the money. And at the end, again, your LCOE costs and your ERR will be much better than on monofacial fixed or even on monofacial tracker. Yeah, next point is, I mentioned before, is the N-type. I think everybody knows the difference between P and N-type. This decision is made in the production starting from the ingot. First of all, a P-type ingot is diffused with boron, and the N-type, and this is the main difference, is diffused with phosphorus. This is the difference in performance at the end, but this is even the difference in the pricing of the ingots. Next step, after having sliced and having produced the wafers, is the top zone layer of the front side. With P-type, you have, that means with a boron diffused wafer, you have a diffusion of phosphorus. And the opposite is for the N-type, you have a diffusion with boron. This is the only difference. The rest of the production process stays the same. Completely, metal contacts, wiring metal, lamination, and so on. This is all the same. So basically, you see here how it works generally for a cell. You have always a PN transition. The PN transition comes here from a P region and an N region. The P region is here acceptor for electrons, and the N region is the donor for electrons. That means the phosphor offers 1 electron more, and the boron has a lack of 1 electron. That means here is a hole, and here is a plus of an electron. And in this center zone is done the PN transition. So if you produce a module or a cell with a P-type, N-type, for P-type, you increase with P region, you make it bigger, and the neutral N region is becoming smaller. The other way around, the N-type, you increase the N-type zone, neutral N-type zone, the blue one, and you have a very, very small region for the P. And the energy comes here from in the center, in this part here, is done the energy for, we have some kind of a tension between the two zones, and here the transition of the electron is made, and at the end you have two different cell types, the P-type with a P region formatting the bulk, and the N-type for the N region is formatting the bulk. So you see here two difficult cell types. P-type, the bulk is formed by boron diffusion, and the N-type, the bulk is formed by phosphorus diffusion. And the top zone here, this is what I mentioned before. This is the N-type zone, the red one. You remember my picture before. And the same is here for the N base. And you have here the zone with the boron P plus zone. At the end, the rest of the cell technologies, you can do everything you want. You can form even whatever a PERC or some derivations of a PERC or further developments of PERC or even TopCon or whatever. At the end, the basic is here N base, P base, and the rest you can do. Here's our product portfolio with the N-type. We have 60 pieces and 66 pieces based on tiling ribbon technology, 9 busbar, and the same here, 78 pieces monofacial, bifacial, again 9 busbar up to 475 watt peak. And for the transparent backsheet version, we have been on the final list of the Intersolar Award this year. very proud having that. Very interesting for you to know, all in all, they have the same first year degradation 1%. And when you have 30 years of warranty with a degradation, annual degradation of 0.4%. This is thanks to the better performance of N-type. And one of the reasons for this better performance is your advantages. You have nearly no LID effect. You have nearly no leachate effect. And this is why we can give a better performance warranty for them. And at the end, you have lower losses in the N-type bulk. That means less recombination processes and less losses even for resistance in the transport of the electrons inside. And all in all, an N-type cell is better to tune to put out more efficiency about that. You can see here efficiencies are starting with 20.68%. Yeah, around about with all black. All black is always a little bit low in efficiency, 19.82%. And this is rising up to 21.16% for the monofacial 78 pieces. Yeah, one of better performance reasons is the better bifacial factor. The better bifacial factor means that the p-type has in generally 0.7 and the n-type has 0.85. So at the end, you can see here the performance is better. These are the two columns, n-type, p-types, in the same conditions, in the same tilt, with different albedo effects. You see here it's always between maximum 3% more energy generation. And with at water, with the lowest albedo, you have a plus of 1%. Bifacial factor you see here, p-type, n-type, in the average it's 85, but you see here around about a plus of 17%. So the resulting energy gain is around about a plus of 0.52%. At the end, you have always lower working temperature. This is the same, responsible for better performance and the higher energy output. And again, it is the same location as we have seen before. You have here a comparison between N-type bifacial, P-type bifacial, P-type monofacial, and the ambient temperature. And at the end, you see it's the temperature is really lower. Yeah, round about. You see here 2 degrees, 1.5 degrees, round about this. At the end, you see here a third-party testing result. And the third-party testing result shows you compared p-type, n-type, plus of energy output of 2.5%. And I think this is worth the installing of and thinking about installing the n-type modules. So here to the end, you see the linear performance warranty. We have a 15-year product warranty. We have a 30-year linear power warranty. You have an annual degradation of 0.4% with initial degradation of 1%. And at the end, this you see here, after 25 years for the p-type, 83.1% of rest guaranteed power output and 87.4% for the n-type after 30 years. And this is the basic difference thanks to all these properties what I've shown before. Okay, now I think we come to the end. Thank you very much for listening. For any questions, we are open. Just call us and we are here for you to answer your questions. Thank you very much. Bye-bye.